Alright, is that any better? Okay. Sorry about that. That means this video is going to be in two parts, turns out. I had to close everything down and restart it real quick. Yeah. Well, it looks like the connection is fine. It's just the my document camera disconnected and wanted a break or something. Anyway, so with part D, so we found the probability of both was 13 over 50, and so we combined all of those together. We got 36 out of 50, which comes out to be 0.72. Okay. Part E, what is the probability that an appliance selected at random is black, given that it's a dishwasher? Okay. Now, whenever we see given, this is our conditional probability. So the probability of B given A is equal to the probability of A and B divided by the probability of A. And you'll have these formulas provided as part of the test. So we need to figure out, okay, what's the probability that a random appliance meets both requirements? That is a black dishwasher, basically. And so for our dishwashers and appliances with a black finish, there'll be 12 appliances overall that meet both requirements. Alright, and then what is the probability of A? Now A is the one that's given, which in this case is given as a dishwasher. So that's last, or so that's on the bottom. And so the probability of a dishwasher, we already calculated that, is 25 over 50, which is 0.5. Now, if we take 12 over 50 and we divide 25 over 50, the 50s are basically going to cancel. So it's 12 over 25. And if we divide those, and that'll be 0.48. Okay. Okay. Sorry for that. So the given one, the conditional probability, that tends to be the trickiest one here. I've also seen a number of students that have trouble with the addition rule, the OR statement. So if we do have the OR statement, make sure we apply the addition rule and do the three different calculations and add them together, or combine them together. Okay. Next, number 4. 3 events are represented by the given outcomes from choosing the numbers 1 through 10 from a hat. Thus, there are 10 possible outcomes from the selection. Now we define 3 different events. Event A has the outcomes 2, 4, 6, 8, and 10. It's an even number. Event B is numbers that are powers of 3, which are 1, 3, and 9. And event C is choosing a number that is less than 4, so that is 1, 2, and 3. Okay, so we want the probability of each of these first. So the probability of event A has 5 outcomes possible where it's successful out of 10 total outcomes, so there's really a 0.5 probability that event A would be true or successful. For the probability of B, we know here we have 3 outcomes, so the probability is 3 out of 10, so 0.3. And probability of C is the same. We have 3 outcomes out of 10, so 0.3. Okay. Question D, we want the probability of B and C. Now, when we say B and C, this is the intersection of B and C. So in this case, we're looking at the 2 lists of numbers for B and C. We're looking at how many numbers they share in common. You see, both of them have a 1 listed, and both of them have a 3 listed. Okay? So that means there's 2 outcomes that they have in common, the 1 and the 3. Out of 10 possible outcomes, so the probability will be 0.2. Alright, and then question E, we have the probability of B or C. Now again, with OR, we want to make sure we apply the addition rule. So according to the formula, this is the probability of B plus the probability of C minus the probability of B and C. Now, at this point, we've already found all 3 of these things. Probability of B, we calculated as 0.3. Probability of C, we calculated as 0.3. And probability of B and C, we calculated as 0.2. So 0.3 plus 0.3 minus 0.2, that gives us a value of 0.4. Okay, part F, we have the probability of B given C. Now, according to our conditional probability formula, that means we want the probability of B and C divided by the probability of C. Whichever one comes second is the one that's on the bottom. So we get both of them in the numerator, B and C. And then the second one, the one that we assume, or we know already has happened, we put that on the bottom. And again, we've seen both of these values already. The probability of B and C is 0.2. And for probability of C, that's 0.3. And then we just divide 0.2 by 0.3. And that gives us 0.667. Okay. Problem G, or part G, we want the probability of A or C. Now, again, this is the addition rule with the OR statement here. So we know this probability of A plus probability of C minus the probability of A and C. Now we already calculated the probability of A as 0.5, and we already calculated the probability of C as 0.3. But what we need to go back and calculate is A and C. Now again, A and C, that means we're looking at those two lists of numbers. Are there any numbers that they have in common? A is 2, 4, 6, 8, 10, B, or C is 1, 2, 3. So 2 is the only number that the two events have in common. So there's one number in common between them. And therefore, a 1 in 10 or 0.1 probability of that occurring. And we combine those together, and that gives us 0.7. Okay. Okay, and then our last part, H, with the probability of A and B. Now again, this is our AND statement, so we want to go back and look at the lists for A and B. And see, what do they have in common? A is 2, 4, 6, 8, 10. B is 1, 3, and 9. Now, we look at those two lists, and there don't appear to be any numbers in common. These are all even, and these are all odd, so there's nothing in common between the two of them. Therefore, the probability of both of these events being successful at the same time is 0. Or we could say it's mutually exclusive, or we can say that they're disjoint. But either way, probability is 0, because it's just not going to happen to pick a number and have it be both an even number and an odd number at the same time. There's no such number. Alright. So that takes care of number 4. Okay, number 5. A game is suggested to you at a party. A person has the numbers 1 through 10 in a hat. You will pay them $1 to play. If you draw 1, 2, 3, or 4, you pay them an additional $1. If you draw 5 or 6, you win $1. If you draw 7, 8, or 9, you win $2. And if you draw the 10, then you get $3. So we know $1 to play, 1, 2, 3, 4, we pay an additional $1. 5 and 6, you win $1. 7, 8, and 9, we win $2. And 10, we win $3. Okay. Alright, so here's the table that we want to fill out. And on this table I've given you 4 rows. Okay. And our outcomes are broken up as we see here. It could be a 1, 2, 3, or 4. That has one outcome associated with it. 5 and 6 could be our second. 7, 8, 9 would be our third, and 10 would be our fourth. Now, when we take into account how much money we've won, we have to include the dollar that we paid up front to play the game in the first place. So we pay $1, and then if we draw a 1, 2, 3, or 4, we pay another $1. That means we're down $2 if we happen to draw 1, 2, 3, or 4. We lost $1, then we lost another $1. Okay. If we draw the 5 or the 6, we paid $1 to play, and then we won $1. So overall, we're right back where we started. We neither have more nor less money than we began with. Paid $1, then we got it back. Okay. So our net winnings are actually 0 in that case. 7, 8, or 9, we paid $1 and then we won $2. That means we now have $1 more than we did previously. And finally, with the 10, we paid $1 and then we won $3. That means we now have earned $2 more than we previously had. Okay. So for our probability, there's 4 outcomes here where we could lose $2, and that's 4 out of 10 outcomes. So that'll be 0.4. For 5 and 6, that's 2 outcomes out of 10. 2 divided by 10 is 0.2. 7, 8, 9, that's 3 outcomes out of 10. 3 divided by 10 is 0.3. And to draw the 10, that's just one number out of the 10, so 1 divided by 10 is 0.1. Now, this should add up to 1, as it does. And we need to calculate this last column, because what this last column is going to allow us to find is the expected value. Once we add those numbers together. Alright, so we multiply -2 times 0.4, 0 times 0.2, 1 times 0.3, and 2 times 0.1. Now we add those together, so minus 0.8 plus 0.3 plus 0.2. That leaves us with an expected value of -0.3. Okay. So the second question here is, on average, is this a fair game? Or what is the expected value, and then what is this a fair game? Well, our expected value is -0.3, so we expect to lose 30 cents every time we play the game. And again, that's on average. And the other part of the question is this a fair game? Well, a fair game is any game where the expected value is 0, and this time the expected value is lower than 0, therefore it's not a fair game. Okay. I don't know why that's not focusing. There we go. All right. Okay, problem 6. It has been reported that 63% of adults aged 65 and over got their flu shot last year. In a random sample of 300 adults over 65, find the mean and standard deviation of the number who got their flu shots in this binomial experiment. And we know it's binomial because either they got it or they didn't. So they were successful at getting a flu shot or they failed to get a flu shot. Okay? So we have 300 in the sample. And 63% success rate based on last year's results. And those are the two key numbers that we need from this problem. You'll notice that the number 65 is mentioned twice, but we want to be careful that 65 is really just providing context for the problem. It's not a number that we need to include as part of our statistics. So we'll say N, that's our sample size or number of trials, is 300. And P, the probability of success, is 0.63. Now, we want to find the mean. Now again, the mean, mu, we said was equal to n times p. So we would multiply 300 times 0.63. And that comes out to be 189. And for the standard deviation, we know the square root of n times p times q. And so the question is, what is q? Well, remember, q is our probability of failure. And q is equal to 1 minus p. So if we have a probability of success of 0.63, q equals 1 minus 0.63, which means it's 0.37. So we have square root of 300 times 0.63 times 0.37. And that comes out to be 8.362. And So that's the four things that we're looking for here. I don't remember if I asked you for Q specifically. Yes, I did. I did ask for Q specifically, so that is one of the answers that we had to find also. Yeah, so this problem has 5 answers, but the hope is that it's really easy. For N and P, we just have to identify what those are from the scenario presented. Sorry. And then from that, we can figure out what Q and then the mean and then standard deviation are, based on our formulas. Okay. So that takes care of number 6. That just leaves number 7 for us. Seven is our binomial distribution. It continues with our binomial distributions. A recent study found that 50% of teenage consumers receive their spending money from part-time jobs. 20 teenagers are selected at random. So right off, that tells us that N is equal to 20 and P is equal to 0.50. Okay. So, now based on this, we have 3 different questions. A, find the probability that exactly 12 of the teenagers selected will have a part-time job. Okay. So that means we have x equals 12. That's the scenario we're trying to find. So anytime it's just a specific value, that means we use Binomial Pdf on the calculator. Okay. So we go second, and then on this calculator data, we arrow right distributions, and they arrow down until we get to Binomial Pdf, which is option 4 here. We press enter, and enter again. Now, number of trials, in this case N, the sample size is 20. Our probability of success we defined as 0.50. And we have x equals 12, which is the number of successes. Then we go down to calculate. So we get a result of 0.120. Again, go into 3 decimal places. So 0.120 is our probability of choosing exactly 12 out of 20 that are working part-time. 12 out of 20 teenagers working part-time. Okay. B, find the probability that at most 6 will have a part-time job. Now, if we say at most 6, again, we want to make sure we interpret that correctly. At most means less than or equal to. Okay? It means no more than 6. So we go, x could be anything from 0 up to 6. Now, again, we can use the table in the back of the book to find this, and we would just add each of those values together, and that would give us our total. Okay? If we have a range of numbers like we do here, we are going to use Binomial Cdf on the calculator. Clear out of that. So we press second data, go over to distribution, and arrow down to Binomial Cdf, which is option 5, we see. Okay. Now we still have 20 individuals. We still have a probability of success of 0.5. But for x, since we're looking at the x being a range from 0 to 6 values, then we'll use x equals 6 in the calculator. So whichever the maximum value is, that's my projector did it again. Sorry guys. 1 second.